The next chapter would be network programming, and this is quite an important chapter. So because nowadays people tend to use Python widely in the field of automation, in the field of networking. Uh, so basically, in infrastructure building, DevOps. So anything which involves DevOps. DevOps is nothing but the operations which is involved inside the infrastructure to automate all those stuffs. So we tend to use a scripting language. So Python is mostly widely used nowadays in industrial automation. So other languages, JavaScript or Perl scripts or just the shell script, but Python we would prefer because there are a lot of libraries, networking libraries, and other required libraries built in, which makes it really easy to implement in infrastructure level. So, and also a lot of monitoring tools. Uh, so a lot of monitoring tools could be built using Python. So a script, Python scripting using all these networking libraries which is available. So the main networking programming in Python is concentrated towards two. One is the lower and one is higher level. So people tend to use the higher level programming part of the in Python a little bit more because the libraries are already built for such protocols. So the higher level programming part is nothing but is a specific application level protocols, basically to access application level network protocols, so such as FTP, HTTP, and SMTP, or SPOP, anything. So anything which comes in the application layer protocol. So Python has a library for that. So, and lower level implementation is nothing to do, it has to do with the transport layer. So it either uses a TCP or UDP for communications. So lower level implementation in Python happens through a protocol called as sockets. So it's a bidirectional protocol, communication protocol. So, or you can call it as a channel built for communication. So the sockets are basically it. The name came from in the system level, where you want to communicate between two ends. It's a bidirectional, and you set up connections at two ends. So basically, it's an endpoint of two bidirectional communication. So in a networking implementation, software could be either implemented in using the TCP or UDP. So we are not talking about the socket level of operating system. We just concerned about the networking layer level of sockets. That's either TCP, that means fully reliable with the handshake happens. If you know about the transport layer, you can read more about the TCP and UDP. You don't know about the transport layer protocols. UDP is a connectionless protocol where you don't worry about the delivery of the data. So you don't set up a connection, so you just send the data and assume that it has delivered, and you don't worry about the whether it has delivered or not. So Python provides a socket library. So all you need to do is import socket, and it has a set of bunch of operation to be performed. So when you set up a connection, so it will be having two ends. So we if it's not a peer-to-peer system, we always call it as a client-server model. So one will always be a server and one will be a client. And if it's a peer-to-peer model, both the ends will have both server and the client standing in its end. So let's compare and try to create one server client server simple application, and also let's see what and all methods are available on those ends. So when we create a socket with basic attributes, we pass our arguments are family, it requires a type and the protocol. So ideally these are the attributes, and you can look more about it. So the socket types are ideal family are either A Unix or the A finite. So you can look into a look. So if you want to know about it, you can go to the documentation of sockets and look into that. So, or see implementation of it. So, and socket type is either it's a datagram based, so that means either it's a UDP or it's a stream based. Stream based is a TCP. So either one of the protocol it has to use in the transport layer. So by default it picks up a stream, and so protocol you don't have to specify. By defaulting it's 0, and we don't specify any one of them if you have a simple application to build. And server socket methods, so server side with pocket, so socket has to have these three methods implemented. So once we have a socket object, it will have a bind, listen and accept at the server side. We have to implement these three operations or methods. So and the client side has to implement only connect, and there are several general socket methods that will be used both at the server and the client end. So that those are receive and send. Obviously once the connection is set up, you have to be able to send and receive the data, and the receive from and receive to send to, these are for the datagram. That means it's for the UDP implementation, and you have to close, and you have to be able to get the host name from the connection. So this is a server and the client implementation. So we won't be able to exactly emulate this in the Jupyter notebook, since we have to run one of the client or the server program in the background. So let's run this in an Python terminal shell. Okay, so let's go to the script folder. So and in the script folder we have a networking, and actually let's look into the code first. Okay, so let's look in directly over here. So start with the server part. So server basically imports a package called socket, and we are not adding any of the arguments which we have specified, like family or types, socket types or family, and the port. By default it will be whatever specified, it would take that, and we are going to build a simple application. We don't worry about that right now. So it returns an object, a socket object, and this socket object we have to, as we have seen here, we have to implement these three methods in the server side. So the first thing we have to do is we have to bind the host name. So we have to get the host name through the socket, and we have to bind that particular host name to the port. So we can specify any port. So let's name it as 1234. We bind that port, and what happens is this port is a server port right now, and it will be live as a server port. And once we have that, it starts listening to the it's so we do a listen, and we say that we are accepting up to 5 clients in this particular port and in this particular host. And once this listen happens, we have to accept a connection. So this accept connection is a blocking connection. So what we'll do is we'll do a true operation, while true, that means it's a loop, infinite loop. And once we accept a connection, once a client tries to connect to the server, so we can, so let's look into the client. So once a connect happens, what happens is this blocking call will terminate, and this will get executed, and then after that it's going to send to the client this thank you for connecting message, and after that it's going to close, and again it will wait for the connection over here. So this becomes a looping. So what happens is once you get a connection, it sends a message and again goes back to close this connection, and it tries to listen to that. If there is any open connection, it tries again for the other clients. So in the client side it's pretty simple. We do the same thing over here. We give one port, whatever port we want to give to the client. Sorry. Okay, so let's name it as 1234 here. And we try to connect to that host and that particular host port. Once it gets connected, so what happens is we have this receive block will be again a blocking call in the client end. So what it's trying to do is it's trying to wait for the receive uh, callback to get executed. So it's a blocking call, and so it's basically, you can say it as a handler, receive handler, and whenever this gets executed, receive will be called, it triggers, and you will get a response back. Okay, so once you send the data here, this will get executed, the blocking will terminate, and then again we are going to close it. So that's all about one-time connection setup in the client side. So let's run this. So the running is pretty easy. So all we have to do is Python 3 and then give the socket server. So we have to run one of the programming. So let's run the, so anyway we have to run the server in background because server will be always listening. So I'm going to run this in background. Okay, so it says this is already in use. So let's change the port to say 123, and in the server also let's make it 123. Now run it. It says okay, bind to the port. So there is some issue with this. I think it's a port which is not available. So let's make it like really big. So 1 2 3 4 5, and let's add okay, let's make it something like 10,000. That'll work. Let's add 10,000 here. This should run. Okay, so now, so the problem usually occurs when the port is already in use by your system. So anything which is less than 1000 will be used. They are generic ports. So the port, when we talk about the ports, these are application ports, and those will be used by some or the other application. So you have to be careful while choosing a test port, or you can always do a test scan on your system by doing a netstat. So the one way is to do is so you can use the netstat in Linux, and you can grep for the particular port. Okay, although there is not 1 2 3 available, but I think 1 2 3 4 are okay. So none of them are in use, but still sometimes it throws an error. Okay, so now we have our server running. So as you saw here, it went to the background with this particular process, the socket server, and it's there in this particular process ID. So now all we need to do is we need to run the client side. Okay, so it gave an error in the client side, sorry, in the server side. Let's serialize it. So let's convert this to byte and then check. Sorry, I'm going to close that. So we have the port number here. So let's, sorry, the process ID, let's kill that. So I have exited the server program. So let's run that server again in a background. It says already in use. Okay. So let's change the port. This usually happens. Okay. Now let's run the client part. Okay. Now what happened here is, so as you can see, so there will be some encoding issues always. So you need to be careful in debugging. So since it wasn't accepting the string, so I had to convert to binary and then send it. And now what happened is, now I have sent a request from the client. So since I have sent a request from the client, so I'm just printing out whatever response that has been sent from the server. So got connection, so thank you for connecting would be print from the client end, and got connection from this it was printed from the server end. It was running in the background. Although it wasn't running in the background, it was running in the background. It will always put its data to the standard output. So you can send it multiple times, you would get the same response. But the one thing to observe here is, so the client side port always changes with the different connection it tries to establish with the different port number, and the response and the address will be always same. So you can also try to kill this particular process. So now, yeah, this is a process. So this is server now, and I'm going to kill that. So since it's killed, now if you send a request, it's going to send a connection error. So connection refused because the server isn't alive and you won't be able to connect to that port. Yeah, so this is about the simple socket program, how it's going to work. So people build their application on top of the sockets. Uh, so there's something called as WebSockets, which is built on top of sockets. WebSocket is a bidirectional protocol. So where you don't have to poll the server every time. The server gives you the data whenever there is a data. So you can read about a WebSocket, which is built on top of socket programming. So, and which is like pretty widely used in where you want data to be communicated from server and the client always, and you don't want to poll for the connection every time. So bidirectional communication so becomes pretty easy. So you can take WebSocket as one of the implementation of the socket programming. So we covered the basic of low level socket programming. So the higher level implementation on it are, so there are a lot of libraries, and we don't have to worry about the implementation here. So we just have to worry about how to invoke those libraries. So the networking libraries for HTTP are HTTP URL lib, XLM, RPC, and there are FTP, POP3, IMAP4, Telnet, Gopher, all the protocols. There are libraries available. Let's try one of the. Okay, so we're gonna add the request as well. So request is also one of the libraries and pretty famous one. So request library is used widely to communicate with the HTTP servers. So basically whatever methods it has, like get, put, post, delete operation could be done with the request, and basically can communicate with anything like raw data, or you can in the post it can send JSON, it can send payload, all those stuff. So let's take one dummy example here. So as you can see, this is one JSON placeholder site. So there yeah, so it works. So basically we are going to do a get operation. Get operation is nothing but just writing an address in the browser. So we also got a response over here, the same response we would be getting if we run this. So we already so we got the response over here. So this is a JSON response from this body. So similarly you can make any kind of request. You can make a post request, update a server, and there are a lot of APIs which would be given by the third-party servers. You can use requests to perform operation on those kind of servers. So, and you can use later you can use any kind of data manipulation, such as JSON or encoders, or you can convert to XML from JSON. You can write to a string, you can write to a file, database, anything. You can do whatever you want to do with the data. So this is pretty high level introduction about the networking libraries and networking programming in Python. So you can dig into more about networking programming, or searching about the WebSocket, or about the HTTP drivers, or any other so you can look into the asynchronous networking libraries in Python. So most of the frameworks, web frameworks, run on asynchronous nowadays with the async type of frameworks, and there are a lot of networking libraries which run asynchronously, such as Greenlet, Eventlet, all those things. You can look into more detailed your documentation would be available, and And that's it from networking programming side for now.